This call is now being recorded.
Okay, let's start for chapter 14 here. Let's start with these questions. Maybe I'll give you 15 minutes to do this. Oh, okay. Did you get the answer for number 30? Don't forget the chain rule. Okay, let's discuss this. So, number 13. Good. So, xy is 5y plus okay. So the first derivative of x, partial derivative is xy is this one. Uh, you minus the power first, then you derive the one inside the bracket, right? It's a chain rule, right? So in here you have just to derive the one with the x, which is this one is gone, so 0 plus or x or xy, so something like this. Is it so? I think you forgot about the 5y power of 3 here. Let's see. So it's 32 x1. Should be like this, right? So you have to keep this one, and the second one is same as previous one. So times the derivative in respect to y. So this just became 15y plus 2x squared. Oh, sorry, 15y squared. Oh, wait. I got the wrong question. This one, number 13. Oh, you you read the wrong question. It's correct, right? It's something like this, right? Okay. I'm confused for a little because everyone has the same answer. Okay, so this is the answer for the number 13. So don't forget about the chain rule here. So you have to keep all of this in place inside the bracket. Then you have to derive what's inside the bracket next to it. That's how I got to work for the chain rule. Okay, have any question about this one? No? Okay. Let's move now. Number 14. Number 14. Okay, I think that's correct, but we can simplify that. Okay, so GV is U plus 2V over U squared plus V squared, right? If you derive it in respect with U, so this become like a product rule. What's that called? That's Ux and V minus Vx and U over V squared. So you can derive this one in respect with U, so this is just 1 times U squared plus V squared minus 2U, derive this one, times U plus 2V over U squared plus V squared squared. And you can simplify this one by V squared minus 4UV, this one minus U squared all over U squared plus V squared squared. I think it's same, yes. Uh, and partial derivative of G in respect with V is just the same, but you have to derive it in respect with V. So this just became 2 V squared plus V squared minus 2V U plus 2V all over U squared plus V squared squared. So this became 2U squared plus 2V squared minus 2UV minus 4V squared. So final answer 2U squared minus 2V squared minus 2UV all over this one squared. U squared plus V squared squared. Okay, have any question? If not, then let's move on. Number 15. Alpha alpha squared ln alpha squared plus beta squared. That's the answer for number 15. To alpha. Yep, that's correct. So the first partial derivative of f in respect with alpha, you have to use product rule here because you have two functions, right? This one and this one. So first derive this one to alpha and multiplied by ln alpha squared plus beta squared plus this is the same alpha squared multiplied by the derivative of this one 1 over alpha squared plus beta squared times the derivative inside the ln here, the chain rule. So it just became 2 alpha. So if you simplify this one, 2 alpha 2 alpha ln alpha squared plus beta squared plus 2 alpha power of 3 all over alpha squared plus beta squared. Okay, and in respect with beta, alpha beta, So this one just you can assume this as a constant. So you have to derive only this one. So alpha squared multiplied by 1 over alpha squared plus beta squared times 2 beta. So this just become 2 beta alpha squared all over alpha squared plus beta squared. Okay, have any question for this one? I think it's very simple, right? Phone number 16. G X Y Z. So okay, yeah, any answer for this one? Okay, let's discuss this one. So G graphic irrespective X y C is, you can just ignore this one, right? So assume this as a constant. So C, the derivative of XC is just C times e power of XC times sinus Y over C. Yeah, just like this one. And G in respect of Y, X, Y, C. Assume this as a constant again, e power of XC times cos Y over C times 1 over C, the derivative of Y over C. Okay, and C1 X plus C. Here you have to use product rule for both of them. So this just become X e power XC times sinus Y over C plus derivative of this one minus cos YC times the derivative inside the cos here. That's just y all over c squared and times e power of xc. Sorry, this one is not minus, right? Okay. Let's see. This one is minus one. Okay, so we got the answer of e power of x times yc minus yc squared cos. Okay, this is the answer. We have to derive x, y, and c. With respect with x and x, y, and z. Okay. Have any question about this one? Okay. Number 17. S U P W U dan up dan square root of W. Okay. Have a answer for this one? Okay, let's discuss this one. SU VW. If you derive it in respect with U, it's you can just ignore this one, right? So just eliminate the U here and just become R plus tan. Sorry, it's P square root of Y W. So it just become this one. And as in respect, to derive it in respect with V, then you can ignore the U here, just write it again. The derivative of R cross tan is just 1 over 1 plus P square root of W squared times the derivative of 1 inside the R cross tangent in respect with V, so this just becomes square root of W. So that's V all over 1 plus V squared W. And for the last one, W, U, V, W, same as before, so this one is all the same. But the difference is only when you derive what's inside the arcus tangent. This one became 1/2 V, V, W power of minus half. Or we can write it UV all over 2 third of W 1 plus V squared W. Okay, something like this. Do you have any question for this one? Nope. Okay. Let's move on. Next question. The second partial derivative. I'll give you maybe 15 minutes again to do this. Okay, did you get the answer for number 19? Yes, that's correct. But you also have to search for f x y and f y x. So let's start from the first one. Fx is just stuff x squared minus y squared, right? And fy is just minus x to y or minus 2xy. And the second derivative of xy is just 24x. Second derivative of xy is just minus 2x. And second fxy is, so you derive this one in respect to y. So this just become minus 2y. And fyx xy, derive this one in respect with x for the second time. So this just become minus 2y. And this is the same. For this case, this one is xy and yx. Okay. Have any question for this one? Okay. Let's move on. Number 20. 20. So c is equal to x minus 2y. Cx is just equal to e power of minus 2y. So cxx is just 0, right? This one is a constant. We derive it in respect with x, so it is just becomes 0. And cxy, derive this one in respect with y, so this just becomes minus 2 e power of minus 2y. And cy, so x minus 2 e power of minus 2y, cyy here, for x e power of minus 2y, and cyx x, derive this one with x, so minus 2 e power of minus 2y. Okay, have any question about this one? Okay. Move on. Number 21. P is equal to R cos F plus 2P. Sorry. Wrong one. F x y c x power of k y power of l and c power of l. What is f x y c here? It's just k times x power of k minus 1, right? yl and c power of l. That's like a usual, but this one is using a variable here or some alphabet. And fy xyc sim L x power of k y power of L minus 1 cm fc xyc semicolon m x power of k y minus power of L and c power of m minus 1. And the second derivative of x here is k times k minus 1 here times k power of k minus 2, right? And times y power of L, c power of L, and same with the rest. C L times L minus 1 x power of k y L power 2 c power of N fcc and c f minus 2. Okay, and let's search for x fxy. So this is the L xk minus 1 y L minus 1 cm. And this one is also similar. So fyx is same kl xk minus 1 y L minus 1 cm and fxc m xk minus 1 y L c m minus 1 and same with this one fcx km xk minus 1 y power of L and c m minus 1. And this one also same with yc and cy. This again lm and lm. Okay, have any question for this one? I think it's very simple, right? Just you have to derive it one by one. Okay, number 22. So let's just discuss it further. PR is cos s plus 2t and VRR is 0, right? Because there's no R in here. And VS is minus R sinus S plus 2t and VS is here is minus R cos S plus 2t, right? And PT here minus 2R sinus S plus 2t. This one 2 is from the chain rule from the TV, right? And VTT is minus 4R plus S plus 2t. And derive the other one VR S. Here this one in respect with the S, so plus minus sine S plus 2t, and same with this one, VR the SR, eliminate the R here, just minus sinus S plus 2t, and VRT, same with the previous one, so minus 2 sinus S plus 2t, same here, so the R, eliminate the R from this one, so minus 2 sinus S plus 2t, and S VST is minus 2 R cos S plus 2t. This one with respect to t, so you get the chain rule again 2 here, and same with this one VTS this one minus 2R cos S plus 2t. Okay, have any question for this one? It's just between calculus 1 again, right? Okay, let's move number 22. So C is equal to xy plus x e power of what? X. So the question is prove that x dc dx plus y dc dx is just equal as xy plus c. So first of all, we can search for dc dx here. dc dx. Let's see, first the derivative of c in respect to x. So this has become y plus, we can use product rule here. We have this one 1 times e power of y over x plus derive this one respect to x, so just minus y x squared e power of y over x times x from this one. So this one cancel out. This has become y minus x of y x plus e power y of x. Okay. And you can search for dc. This one is dy. Sorry, dc dy. Just derive it directly. So this is x plus x e power of x times 1 over x. Cancel out. So this one just become x plus e power of y over x. Just this one. When we get these two, then we can substitute this into this equation. So x times y minus y over x times e power of y over x plus e y over x plus y times x plus e y over x or y over x. So there's xy minus cancel out y e y over x plus x e y over x plus yx plus y e power of y over x, and this one cancel out, minus and plus. And if you arrange this one again, xy plus xy plus x e power of y over x. If you see this one backs to our first equation, right? This one. So we can just change this one with x, so we can get xy plus c, and that's proof the equation. This one. So x dc dx plus y dc dy is equal to xy plus c for this one. Okay. Have any question about this one? Nope. Okay. And if there's no question, then that's all for today. And thank you.